Hello, my awesome Algebra 2 students. Unfortunately, I can't be in class with you today, but we are going to be covering Lesson 2 of Unit 1. We're talking about geometric sequences. So, if you would please, can you get your book opened up to page 11? One of the things that we do in here often is this notice and wonder. So I need you to take a look at these 4 different sequences. A sequence is just a list of numbers in some kind of a pattern. And notice something, wonder something about them. Looking at these, I do notice that they all are in some kind of a pattern. It looks like I am either multiplying by a number, or maybe if it's getting smaller, if it's a decreasing pattern, it might look like it's a division, but we're still going to say that we're multiplying by a fraction. You could be wondering possibly what's the next number in the sequence going to be, that kind of thing. So let's take a look at this and see if we can figure out what the sequence pattern is, what's happening every single time. So for instance, in the first one, to go from 40 to 120, right, that's multiplying by 3. Multiply by 3, multiply by 3. Once the numbers are bigger like this, it might be a little bit harder to just recognize, but you could certainly use a calculator and double check that. But this is multiplying by 3. In the second pattern, it's also increasing, and this time those numbers to go from 2 to 8 to 32, 128, 5, that's going to be multiplying also, but hopefully you can understand, what that is being multiplied by. That's multiplying by 4 this time. The next two are called decreasing functions or decreasing patterns. The numbers are getting smaller, right? In the third one, it looks like it's dividing by 2. Instead of dividing, I still want to talk about these because I'm telling you, we're talking about geometric sequences. It's all about multiplying today. So instead of dividing by 2, can you think of something I could multiply by that would get me the same effect? I could actually multiply these by a half, right? Okay, and the last one is probably the least obvious. It's not as easy to just look at that pattern and see what it is. It is decreasing, so I know that I'm multiplying by a fraction. And if you're ever not sure what that fraction should be, let me go back to one of the other ones. We can take the new number and put it over the old number, and that's going to tell me what I'm multiplying by each time. So in the first one, if I took the 120, which was the second term, and divided it by 40, which is the first term, that's where I can get my 3. Or 8 divided by 2 gives me the 4 that I had right here. If I put this number over this number, 500 over 1000, that does simplify to 1/2. That's what I was multiplying by to get from one number to the next. Now, it doesn't have to be the first number and the second number. In fact, if I was doing this, I would want to use smaller numbers. So I would take the 81 and the 108 and simplify that. If you want to do that by yourself or use a calculator, you can just type this into a calculator and hit equals, and it'll simplify that fraction for you. This is 3/4. So we are multiplying by 3/4. Okay? And again, you could be wondering, what would the next number be in a sequence? For instance, on that last sequence, that fourth sequence right there, multiplying by 3/4, 81 times 3/4 actually doesn't even give me a whole number. In this case, it's going to give me a decimal. You can see the third one there, I had a decimal as one of my answers anyway, but this one does give me a decimal. It's 60.75, I think, or 60.75. Yeah, I think it's 60.75. Okay. So if I was with you in class today, I would be giving you a piece of paper that looks like, let me see if I can scroll down, looks like this big grid right here. It's just an 8 by 10 that has all these squares on it, and I would ask you to actually cut these apart. If I'm not there, I'm not going to have you working on that without me, so I'm just going to try to do it on this presentation. So this says that Claire takes a piece of paper, cuts it in half, and then stacks the pieces, and she takes the stack of 2 pieces and cuts those in half again to form 4 pieces, and stacks those. She keeps repeating that process. The original paper has a length of 8 and a width of 10. Complete the table and describe in words how you can find the results after 5 and 6 cuts. So we don't necessarily have to draw all that out, or if we were actually doing this with paper, we wouldn't have to actually cut them 5 or 6 times, but we certainly could. So for this one, with 0 cuts, there was just 1 piece of paper. I'm going to get a different color here. So there was 1 piece of paper, and the area of that, because it was 8 by 10, we find the area by multiplying, right? So 8 times 10, that would be 80 square inches for that 1 piece. When I take that paper and cut it in half, so if I would cut it here, and then remember it does say that she's stacking it, so she would take the 1/2 and put it on top of the other half, but she really in effect now has 2 pieces of paper, and we're going to say like this is now gone. It's just going to be stacked up on top of the other one. Now this is a 5 by 8 sheet for how I cut it. If you had cut it the other direction, I'm still going to have the exact same area because it's just cutting it in half. But this would be now 2 pieces of paper, and 5 times 8 is going to be 40 for my area. If she takes that stacked one, I'm just going to know that every time she's cutting it, it's going to double the number of pieces of paper, right? Because every piece of paper is getting cut into 2. So I'm going to take this left half of my paper and we're going to cut that. And then that would be stacked. So we're going to say, you know, this piece is gone. Right now, this is the part that I have left, this top left corner. And that's 4 by 5, and that area would be 20. And remember, we cut all those pieces of paper in half, so now we're up to 4 pieces of paper. Now, if I take that stack and cut it all in half, I'll have 8 pieces of paper. And when I cut this, I'm going to cut it, I guess, this way because it's still easy enough to get a nice even line there. I have a 2 by 5, which is going to give me an area of 10. Hopefully you're seeing this pattern now. I cut it again. I'll have 16 pieces of paper. And when I cut this one, I could still cut it this way instead of cutting through the squares, right? Because otherwise I'd be cutting it and I'd have it cut, you know, have some of the squares cut in half. But if this part is gone away or stacked up, I guess, I would be down to an area of 5. However, now I can't keep whole numbers anymore. This next time when she cuts it, she's going to have 32 pieces of paper. And this section right here is what I had left before I started this one. When I cut that, if I cut that in half and this part goes away, what I'm left with is 2.5 squares, right? 2.5. But again, hopefully you're seeing the pattern. The number of pieces is doubling, but the area for each piece is getting cut in half. It's getting multiplied by half, right? So it says, describe in words how you can use the results after 5 cuts to find the result after 6 cuts. So we're not actually going to try to draw that out, but let's just figure that out right here. If I had 6 cuts, I would have, we're going to double this, so saying this in words, but I'm also going to write it. We would have 64 pieces of paper. And then when I do cut that one, I would have half of 2.5 would be 1 1/4. So 1.25 I could write. Or if I had done this one up here, let me go back to that other color. If I had done this one as like a fraction of 5/2, this could be 5/4 if you prefer fractions. Fractions are your friend. You should like them, but that's what we could have for that one. So then now I want to be able to graph both of those. Okay, so I know that in your book you're going to have to kind of flip back and forth with the pages. I have my book out so I can actually see my numbers there. Be careful with the scale on here. For the number of pieces, every line on here is worth 5. So at 0 cuts, there was 1 piece of paper. So I had 1, which is going to be real close to the axis right there. After 1 cut, I had 2 pieces of paper. And remember, this is 5 right here, so this should be less than half. I know that my pen is making a mark that's way too big right there. At 2 cuts, I have 4 pieces, so still under that first line, but it is growing. And then at 3 cuts, I have 8 pieces. And at 4 pieces, I have 16. So this would be 15. Here's 16. At 5 cuts, I would have 32. And then 6 cuts would be 64, which is off my graph, right? It would be really tempting to connect this and make a nice curve. This is an exponential graph, right? This is 2 to the 0 power, 2 to the first power, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth. However, we don't really have any data in between those points, right? There's no way to have, like, after, let me move this down a little bit so you can see the label on this, but this is about the number of cuts. I couldn't have like 1 1/2 cuts, so I wouldn't want to connect anything between 1 and 2. I wouldn't have 2 1/4 cuts, so I wouldn't have anything in between here. So this really should be a discrete graph where I've got these separate points. If you just automatically went ahead and connected them because that's what you're used to doing, I understand that, but keep in mind that we don't always want to connect our graphs. The next one says that on this graph on the right, it says sketch a graph of the area of each piece as a function of the number of cuts. And can we see how the area is changing with each cut? And we already figured out how it's changing. But at 0 cuts, we had 80 square inches. At 1 cut, we were down to 40. It got cut in half. At 2, it was at 20. 3 is at 10, 4 is at 5, 5 is at 2 1/2. And then 6 we could actually graph this time. It's really just 1 1/4. And same thing, because it's based on the number of cuts, we don't have fractions of cuts, so we shouldn't really connect those points. Okay. So we're going to skip over that "Are you ready for more?" just in the interest of time as I'm making this video. And we want to be able to fill in blanks for the missing numbers here for our geometric sequences. So hopefully you can see the patterns and figure out what's happening here. By the way, the number that we are multiplying by every single time is called the growth factor. So we're going to be looking for what that growth factor is in each sequence. So in letter A, to go from 1.5 to 3, and then 3 to 6, that's getting doubled every time. So the growth factor is actually going to be 2. I'm just going to write that over here. So 6, we would go to 12. When we double 12, we get 24. Double 24, we get 48. In letter B, this is going from 40 to 120 to 360. This one should be familiar because I believe it was at the beginning of the lesson. So this one has a growth factor of 3. We're multiplying by 3 every time. So 360 times 3 should be 1080. And then when we multiply that by 3, we're going to get 3240. Letter C is decreasing, right? It goes from 200 to 20 to 2. Looks like it's dividing by 10. And by the way, it's fine in your head to go ahead and divide by 10. Realize, though, that the growth factor is all about multiplying. So we want to either write this as 1/10 or 0.1. Either one of those is fine. But after 2, I hope that you can figure out what's going to come next. This should be 0.2. Then we've got 0.02 and then 0.002. Letter D has some fractions there. Luckily, they all have the same denominator, which makes that pretty nice. So I'm going to suggest take a look at these two terms that are right next to each other, the 9 and the 27. To go from 9 to 27, I multiply by 3. So if I would try that here, if I would take 1/7 and multiply it by 3, I would have 3/7. Multiply that by 3, I've got 9/7. Okay, so we found our pattern. We are multiplying by 3. That's what my growth factor is. Whoops, sorry, touched something on my screen. And then 27 times 3 is going to be 81/7. For letter E, decreasing again. And it looks like it's getting cut in half. So we're going to use a growth factor of 1/2 or 0.5. I write the word or in letter C, I'm sorry. 24 to 12 to 6, this would go to 3. And then either 1.5 or you can use 3/2. Okay. So after you're done with that, again, if I was in class, it would be a little bit different. I would ask you to actually do this with a partner and figure out some new geometric sequence and be prepared to explain why it is a geometric sequence. And again, I didn't really say the word geometric very much except at the very beginning, but a geometric sequence is when we are multiplying to get from one term to the next term. So if I would start, for instance, with, I don't know, let's just start with a nice easy, let's start with 5, and I want my growth factor to be 2. So I would have, the next number would be 10. Then the next number would be 20, 40, 80. This is actually the numbers that were in our activity with cutting the paper. So that is one example, but you can certainly come up with lots of other ones. All right. A geometric sequence, and this should go in your vocabulary packet, but I can help you out with this also when I get back. A geometric sequence is a sequence in which each term is a constant times the previous term. The constant is that growth factor that we were looking for, and we're going to take the term that we know, the previous term, and multiply it by the growth factor to get that. Today, your homework is on page 15 through 17. I would like you to do numbers 1 through 6. And remember, if you need any help with any of that, you can look in Schoology and the answers are in there in case you get stuck. But feel free to work with a partner in class. Make sure that you're doing your best to try to get this figured out. If you need any help with anything, though, feel free to send me an email.